So hello everyone, we are from group number one, and we're going to start off with part number one. So first is we have batch systems. Example of OS for this is payroll system and bank statements. And the feature for this is basically multiple people send one request to operator, and the operator sends it to the OS. That's how the feature works. And when it comes to applications, obviously it's used in bank statements and to print out payroll system. It is multi-processor, multitasking, also multi-user. The advantages include it can be accessed by multiple people at the same time. The idle time is low and it's easy to manage. Next up is Nathan.
Okay, if you look at the multi-program system, we have basically a multi-program system is the ability of a system to execute multiple programs with only using one processor machine, meaning one computer or one person laptop. So the example here would be the Windows OS or the Unix OS. Also, the feature of this is it keeps several jobs in memory at a time, meaning you can do multiple things at the same time. And then if you look at the application of it is in everyday use. You can use, let's say you can use Microsoft Excel or Word, you can download an app, you can transfer data, or you can browse through your Firefox or Google Chrome and more at the same time. Meaning you can do multiple things at the same time. And it's also multiprocessor, it's multitasking, and also you can be used by multi-users. This actually promotes efficient CPU utilization because you can do multiple things, which promotes an efficient CPU utilization. And it's also it has less response time. So the next column will be explained by Nalini.
Okay, so the next column is time sharing. So the example of OS that time sharing uses Unix, Linux, Windows 2000 and so on. So the features would be each user grabs dedicated time for all the operation, and multiple online users can use this computer at the same time. So these are like the examples, few. And the applications would be this uses CPU scheduling and multi-programming to provide each user with a small portion of time and a shared computer. So the processor is mostly single, but then it also can be multi-processor. And the next one would be it's a multitasking, and the user is a multi-user and also can be a single user. The advantages would be it produces a quick response and reduces CPU idle time. Okay, so that is all for the part one. The part two would be presented by me. So the example of computer networks would be Novell, NetWare, Linux, Sun Solaris, and the list goes on. Okay, so the features would be it has the ability to detect the different HW and share data over several machines. The next one would be the network operating system can be support for internet functionality and their connection management as well. And printer and other applications can be shared, and users can use their backup database and web services. Besides that, the application used by computer network is email, messenger, and instant messaging apps such as WhatsApp, Telegram, and whatnot. Okay, so the advantages would be highly stable, new technologies and hardware upgradation, and server access is possible remotely from different location and the types of system. Okay, so that is all about for computer networks. The next one would be client-server system. The client-server system examples for the OS would be Windows, Mac, Android, Linux. It is an open system, and it has the modularity, and also cost reduction and better utility resources is one of their features. So the next one would be the example of applications, which is email, network printing, www. Okay, and then the advantages would be property management, backup and recovery possible, upgradation and scalability in client server setup, accessibility. Okay, and we have a few there, you can read later. The next one would be peer-to-peer system, which is Windows and Mac OS. Okay, so peer-to-peer nodes have usually both resources and produce resources because if you use it will increase the number of nodes and then enhance the resource sharing capacity of this. Okay, and it is capable of to at once the operating system like Mac and OS and better stability and scalability. Its data is flowing in one side, and these are like few features of it. And the example of applications would be BitTorrent, Skype, G, Nutella, Kazaa. And the advantage would be each computer in the peer-to-peer network manages itself, and it's easy to scale peer-to-peer network and add more peers in the system. The client server handles all the requests, and the provisions are not required in peer-to-peer computing, and save the cost the server has saved. Okay, so that is all about the advantages for peer-to-peer system. The final one would be distributed system. So the example of OS would be clouds, Linux, Condor, and you can see there are many more there. Features would be openness, which offers the service in standards and describable of the syntax, and we can see the other explanation over there. The next one would be scalability. The following would be reliability, and also the performance would be part of the feature. The application would be telecommunication network, internet technology, air reservation control system, and so on. Okay, and the advantages would be the efficiency, scalability, reliability, and also latency. So there's a common feature for all of these, which is all these network system are multiprocessor, multitasking, and also multi-users. So that is all about for part 2. So following will be presented by my friend Nathan. Oh.
Okay, thank you, Nalini. So if you have a look at part 3, we're going to look at the desktop OS. You see, desktop OS is our everyday OS, whereby it's a main control program in a user's desktop or laptop. But it can also be known as a client OS. So the examples would be the 3 main OSs, which is the Microsoft Windows, Mac OS, and Linux. So the features here, I'd say it's a GUI and also a client for other systems, meaning you can use 2 OSs at the same time. As you're using a specific OS, you can use another OS at the same time. How is it applied in the real world? Well, it's used in word processing, spreadsheets, and games, and it also has a user-friendly interface. Okay. If you look at a multiprocessor system, as the name suggests, it is a multiprocessor. It consists of 2 or more CPUs, share the full access to common memory, or in this case, the RAM. It also shares common peripherals and whatnot. So an example given here would be Unix. Okay. So one of the features that makes it a multiprocessor system stand out would be that you can use different types of processors as per your need. Whenever you need, you can add a processor and it will do just fine. And how is it applied? Well, it's used in 3D graphics with audio or video compression and decompression. Now, if you look at the advantage here, this is actually very important. It has enhanced throughput, meaning by if you were to add or with the existing amount of multiprocessors, work will be done fast. Okay, so you're basically utilizing all that power for good use. Okay, so you will get stuff done fast, and also the economic system because it's much cheaper than buying a single process machine with only one processor, and also more reliable because let's say one processor fails, the system does not just fail immediately. You can still use it, but it'll be a little slower. So if you look at a cluster system is basically almost same like a multiprocessor system. The only difference is that it's a combination of 2 or more computer systems merged together, and they also share common storage, and the system works well together. So, but in order for a cluster system to work efficiently, there has to be a hardware cluster and a software cluster. So the hardware cluster enables higher performance disk sharing between the systems, whereas the software cluster allows all systems to work together in harmony. So example of the OS would be Microsoft Clustered Shared Volumes or Oracle Cluster File System. So application daily life, it's used in weather forecasts, it's used in scientific computing and also supercomputing system. The advantages would be great scalability, it's more reliable, some say it's more reliable than the multiprocessor system. It also recovers automatically from failure without user intervention. So the last OS would be real-time system. Real-time system basically an OS intended to serve real-time application, processes data as it comes in, mostly without any buffering delay, because the real-time system is actually quite time sensitive. A certain process has to be done within a certain time constraint, or not it might fail. It all comes down to what kind of real-time system, because there's 2 kinds. There's a hard and also a soft real-time system. If let's say an application fails in a hard real-time system, the system will immediately fail. But let's say if a program can be executed in a soft real-time system, the system will not fail immediately. Okay? There's only a small performance degradation, and that's pretty much it, and it still works. So an application you use in industrial processes, airport traffic control, and distribution electricity, meaning that it's used in time-related activities. And it's also reliable, it's fast, it's easier to test, and it's error-free. At the end, I would also like to say that all these four OSs are multiprocessors, are multitasking, and also involves multi-users. Because nowadays all OSs are like that. So that's all from me. So task part 4 will be explained by Hedvig. Thank you.
Alright, we're moving on with embedded systems. Everybody is, I think, familiar with embedded systems. Like we have our washing machines, phones, cell phones. Everything is embedded nowadays, like Nest cams, CCTVs. So we have OSs like VFX Work, embedded Linux. And the one important feature that I would like to specify from here is the embedded systems are used for specific functions. So each system has its own functions. That is the unique feature of an embedded system. We can read the others, but this is the important one. And when it comes to applications, embedded systems are used in detecting crashes, street light, traffic control, and even your vehicle itself. There's a lot of embedded system that makes up a whole car. That's one of the features of an embedded system, is that it makes up a smaller part of a whole new device. So it's basically like a puzzle. And when it comes to processor, they can be multiprocessor or single, and they can be tasking and multi-user. And advantages is it can be mass produced, and they are made for specific task. And another important advantage is that they can be optimized to use resources efficiently, so they can last for a long time. So that's an important feature advantage of embedded system. Next up, we have sensor node systems. So these sensor node systems are basically sensors like proximity sensors, time sensors, or any sensor. So those OSs like Tiny OS, Light OS, and the features, it is like it's less power consum power consuming, and it's very mobile, easy to move, and it's very easy to scale. And applications include like tsunami detection, environmental sensing, haze sensing, forest detection, and all those things. And when it comes to advantages, it is the advantage of this is because it's a network based system, it is very vast. You can keep adding more and more and get a lot of data back from the sensors, and it is flexible, and it's also very inexpensive. That's why we are able to use a lot of it, because it's affordable and it's very flexible. And the next one is smart card system. So over here we use Maltos. So smart cards are basically have authentication. That's one of the feature. Secure DF encryption, all those things. And when it comes to applications, smart cards are used in banking, telecommunication, and also satellite TV. Okay, this one is smart cards are single processor, multitasking, and also single user, because it's a card. You cannot add a lot of processors inside a card. And advantages include security. It's highly secure compared to magnetic strip cards. It's reliable and multifunctional. And lastly, we have handheld system. So handheld system is like our mobile phone, laptops, anything that's handheld. And we use like Android and Palm OS for this, even iOS. And the important characteristics is like power efficiency. You can use it for a long time, and there's a lot of new functionality inside there, like 5G and like 3D sensing. And that's the important feature of a handheld system. And the applications includes like digital note taking, educational material, IPTV, on the go news and television entertainment, like that. And it is also multiprocessor, multitasking, and it is used by multiple users. And the advantages, the main advantage of handheld device, its size and weight. It is very efficient, and it's instant on. It can be used for a prolonged period of time, a long period of time, without charging. And one more important advantage is the wireless communication. These handheld devices can communicate with each other wirelessly. So that's it for our group. Thanks for watching.